Hello and welcome. This video is aimed at giving a description of our work on the PACE project and the developed solution to enforce GDPR policies for online services which use customers' personal data. This is an EPSRC research project with joint collaboration from Newcastle University, Cardiff University, and University College of London, all within the UK. My name is Kobe, and I will be taking you through the workings of this project. My colleague Frank and I are the main developers for this project, and Frank would come in to give a demonstration of the PACE solution in part 2 of this video. More information about this project can be found by going to the link given below. For this video, we will be looking at the following topics. We will first discuss the EU General Data Protection Regulations, and then give a brief introduction to cloud computing and the limitations in realizing GDPR compliance. After that, we will look at a scenario of a user's online activity and how their personal data is processed. Next, we will look at the GDPR policies which are focused on for this project, and then we discuss the developed solution and the portal which can be used to test the various functions of our model. With increasing usage in online services, a lot of focus has now been on how to protect people's personal information online. The General Data Protection Regulation is an EU regulation on data protection and privacy within the EU and the European Economic Area (EEA). It also addresses the transfer of personal information outside the EU and EEA areas. According to the UK Information Commissioner's Office, compliance is the conformance to a rule or guidelines, in this case the GDPR guidelines, and it's based on 7 key principles as outlined here. We wouldn't be explaining or going into detail on all of them, but only on the ones that have been implemented or considered for this PACE project. Firstly, we have lawfulness. This refers to identifying an appropriate lawful basis for the data processing, and also not doing anything generally unlawful with personal data. Secondly, service providers need to be fair, and this refers to handling people's personal data only as would be reasonably expected, and to not mislead people when collecting their data. The third key principle we have is with transparency. That refers to being open and honest on how service providers process customers' personal data and comply with transparency obligations of the customer's right to be informed. With purpose limitation, service providers need to clearly identify and document the purposes for processing and collection of users' personal information. The next key principle we have is data minimization, where service providers only collect personal data which is actually needed for the specified purposes, and no extra data is collected. The next key principle is integrity and confidentiality, where service providers need to protect the personal data which is collected and stored. Finally, we have accountability, which refers to having appropriate measures in place by the service providers to demonstrate GDPR compliance. Now, the interpretation of GDPR policies can be quite complex, and so we limit the scope of work by focusing on particular points where data breaches are prone. We will further explain this in subsequent slides. More information on GDPR the key principles and their explanations can be found by going to the ICO website at the bottom of the screen. With the focus of this project being on improving or increasing GDPR compliance within cloud services, we would give a brief introduction into cloud computing. Cloud computing refers to the on-demand availability of computer system resources, especially data storage and computing power, without the direct active management of users. Large clouds often have functions distributed over multiple locations, which are known as data centers. Data centers are basically large rooms with racks of servers, network equipment, and other computing resources. Three main paradigms exist under cloud computing, which are software as a service, platform as a service, and infrastructure as a service. With software as a service having the least amount of control for owners or users or consumers, as they are only exposed to applications or ready-made services. With regards to platform as a service, businesses and developers have more control. They are able to host, build, and deploy consumer-facing apps. And finally, infrastructure as a service gives the most amount of control to users, where organizations or businesses or private individuals are able to manage their own resources, such as the network, the servers, carry out configurations on them, and also the data storage on the cloud. Most cloud providers seem to focus more on simplifying applications and their provisioning rather than on compliance. Top service providers like Amazon Web Services and Google Cloud either do not provide or provide very limited support for compliance. They seem to be focused on providing ready-to-use tasks such as serverless computing and function as a service, but the focus remains mostly on the infrastructure rather than on compliance. We also have AWS's function as a service, which users can deploy, run, and manage their applications without worrying much about the infrastructure complexity and management. Now, this limitation has been found by our project, and by this, we are seeking to bridge the gap to improve compliance and thus increase customers' trust in online services. And now, we will consider a scenario where customers need to provide their personal information online to be able to get a service. Our working scenario is an abstraction of a real-life system for providing customer services, and we will be focusing on the aspects that involve the processing or handling of customers' personal data. Here we have an online pharmacy scenario to show the GDPR concerns we focus on for such composite cloud services. Now, a customer accesses the website of an online pharmacy to order for some drugs and needs to provide the following personal information: his ID, health information, bank account details, and address. Here we have Cloud4U, which is a Russian web hosting service provider, and it hosts and manages the website of the online pharmacy. This means that Cloud4U automatically has data of the customer. Now, the pharmacy's website is also embedded with plugins from the social network called FriendFace, and this allows features like and share. These plugins need to access the personal data like the address of the customer for profiling purposes. Beeswax provides a real-time bidding service for the pharmacy for the purposes of advertisements so that the pharmacy can generate alternate revenue streams. This provider needs access to the customer's ID and address or location to be able to function properly. Next, we have the Lloyds Bank here, which is the payment service provider to be able to handle the payment of the drug. And finally, we have the shipping service, Hermes, which needs the address and identification details of the customer to be able to correctly ship the purchased drug. Following our just described working scenario for the online pharmacy, we can identify three main operations carried out by service providers. And these are access operations, transfer operations, and profiling operations. Under each of these operations, there are some key components which we have considered for development to be able to ensure GDPR compliance. Firstly, under access operations, the users have to have given consent explicitly to the service provider to be able to have access to their data. Secondly, the data held on users has to be encrypted by the service providers. Under transfer operations, we have similarly the user consent and data encryption. And thirdly, the destination for the transfer has to conform to GDPR regulations. That means the external third party which is receiving customers' personal information has to either be within the EU, which means it will follow the GDPR regulations, or if not within the EU, it must have some contractual agreement to follow the GDPR regulations or to have standards which are equal to the GDPR regulations. Finally, under profiling operations, we have users' consent must be explicitly given, data held on users' personal information must be encrypted, and lastly, profiling can only be done on users who are above 18 years old. Another policy we focus on for development is the transparency of service providers' activities, and this is handled by the provision of public logs which can be viewed by either users or by service providers or by editors. The compliance monitor is our developed solution to be able to create a privacy-aware cloud ecosystem. It comprises of basically three main components: the compliance monitor API service, the public blockchain network, and then the database. Now, the API service just listens for requests from other cloud applications that are processing customers' personal information and gets the details of this request, and then by working with the blockchain and the database, verifies that these operations are actually GDPR compliant. The operating workflow for setting up the compliance monitor is as we have below. Firstly, it has to be provisioned by installing the necessary JDKs, setting up the database, the blockchain network, and connectivity to the blockchain network within the ecosystem of the cloud service provider. Once this is done, the monitoring tool can be started and it will automatically connect to the other two components, the blockchain and the database, to be able to carry out compliance verification and enforcement. According to the book published in 2018 by D. Loretti, Chesani, and others, compliance monitoring is defined as providing an affirmation that a framework is being adhered to as a watchdog for unwarranted operations and events, and it acts as an autonomous process operating in the second line of defense. For our compliance monitor, it's basically a preemptive API service to listen for data operations which involve users' personal data in the service provider's networks or service. The monitoring tool receives details of the service provider's operations and triggers a set of processes to check compliance. It does this by interacting with the smart contracts deployed in Ethereum's public blockchain network to run a set of rules against the operation requests attributes and determine that the operation is GDPR compliant or not. Operations are only allowed to continue if compliance checks are passed. Then, the results of compliance checks are stored in the public blockchain and can be viewed via a portal. The next component of our compliance monitor is the database. It's basically a containerized data store with limited access to external parties. All users' personal information are encrypted and stored within this database. It also contains information that is necessary for carrying out compliance verification checks. The monitoring tool alone has access to the database, and the service provider needs to make a data write or access request to the monitoring tool's API service. Such requests are also logged locally within the data store and publicly on the blockchain for customers to view the operations on their personal data. The actual verification for compliance with GDPR policies is done within the public blockchain network. In the image shown on the screen, we have an abstract model which connects the parties involved in GDPR compliance. We have the users, we have the cloud service providers, and we have the auditors. Three main smart contracts are used to aid in compliance verification. Firstly, we have the privacy smart contract, which service providers use to set the list of their services. Users are able to retrieve these services and explicitly give consent yes or no to each of them. Now, to carry out compliance verification, we have the compliance smart contract, which is able to verify access, transfer, and profiling operations, and as well to check that data held on users is actually encrypted. Finally, we have the login smart contract, which saves an audit trail of any verification requests carried out within the ecosystem of our compliance monitoring tool. We do not store users' personal information on the public blockchain for security reasons. As part of our developed solution, we have a user interface. This portal provides a mechanism to test out various scenarios and functions of the monitoring tool. Access control is implemented using three main roles, which each have different capabilities. We have the service providers, we have customers, and we have verifiers. Now, service providers are able to log into the portal and set or update the list of their services that they provide. Also, they are able to simulate access, transfer operations through the user portal. Next, we have customers. Now, customers, by logging into the portal, are able to view the list of services given by a service provider. Then they can give their consent to each service explicitly with a yes or a no. And finally, they can view logs pertaining to their own personal information and how they have been used within the cloud service provider's ecosystem. Finally, verifiers are able to view logs of compliance verification checks which have happened within the ecosystem. And this is done by pulling the records directly from the blockchain. Thank you for taking time to watch this video. Please watch part 2 of the video to get a detailed explanation of the various features for our developed solution.